A dilution. All right. Yes. I can't mute myself because I'm recording right now. You can mute your Chrome tab and you won't hear me anymore. So you can right click on your tab.
Well, just turn the volume all the way down.
All right. Welcome to another Schleicher recording, live lesson. Y'all, please feel free to interact with me during the lesson still. Today we are learning about molarity and dilutions. So most of the stuff is just making sure you know the vocabulary, but then you're able to just kind of do some calculations as well. So by the end of this lesson, you should be able to define what a solution concentration is, define what molarity is, be able to do some molarity calculations with that, be able to define what exactly a dilution is, and then perform dilution calculations with that. So measuring concentration. So when we talk about concentration in general, we're not talking about focusing on something really hard. In chemistry, concentration really means how much solute is dissolved. Okay, it's like a measure of how much solute is dissolved. So if something is more concentrated, we have more stuff dissolved. If something is less concentrated, that means we have less stuff dissolved. Can you think of examples from your life where concentration of solution matters? Have you all ever heard of things from concentrate? Yeah, like lemonade. So like lemonade or other things from concentrate. Those generally come in very concentrated form, and then you have to dilute them. You have to like make them less concentrated by adding some water. Other things that might be, okay, maybe soda machines. Like they don't actually hold that much soda, right? They actually have some super concentrated like soda syrup, and they run like carbonated water through that, and then that's how they dispense all that soda. Or Slurpees. Slurpees are good too. I kind of want a Slurpee lately. What else? What else? Well, maybe like detergents in general. So like, for example, if you ever use a Tide Pod or eaten a Tide Pod, you might notice that it's very concentrated detergent, and you almost die. But like it gets less and less concentrated when you have all that water added to it, and it's able to wash your clothes, and your clothes don't smell like the most concentrated Tide Pod ever. It just smells like, generally nice. Like it's kind of a less concentrated smell. So how do we measure concentration? Like we can talk about concentration all day, but we need to put numbers to it. So the number that we put to concentration is called molarity. So the most used expression of concentration is this molarity, and we tend to use a capital M as the abbreviation for molarity. So molarity is known as the number of moles of solute dissolved in a liter of solution. So if you don't know the number of moles, you need to solve for number of moles first. Like if you have grams, you got to convert to moles first. And this is represented by our capital M. Sometimes it's italicized, so it'll be like a little slanted. And the units are going to be moles per liter, MOL/L. So if you're looking for like an equation for molarity, a molarity should be equal to moles over liters. And whenever we talk about moles, this is moles of solute and liters of total solution. So what is like, how much space is your total solution taking up? That's the liters you're taking into account here. Okay, so for example, to make a 1 molar, oh, by the way, whenever I say something like molarity, and there's M right after a number, you read it as molar. So to create a 1 molar solution of aqueous NaCl, you just have to measure 1 mole of NaCl. In this case, it would have 53 grams of mass because that's the molar mass of NaCl. And you just add 1 liter of water to that. And if you have 1 mole divided by 1 liter, that means it's 1 molar solution. And you can play around with that a bit. You can be like, well, what if I add 2 moles? Okay, then you have 2 molar solution. Well, from there, what if I half the amount of liters I have? Well, then you have 4 molar solution. And there are some math relationships there, but we're just going to go straight into some practice problems to see how we solve these on our own. So, for example, if 5.7 grams of KNO3 was dissolved in 233 milliliters of water, what is the molarity of the solution? And here's a hint. You might have to convert from grams to moles and from milliliters to liters first. Like these are required. You can't have any other units. It has to be moles and it has to be liters. Okay, so we know our molarity equation is molarity, or capital M, is equal to moles divided by liters. So let's figure out how many moles we have, and let's figure out how many liters we have. All right, so in terms of moles, we do not have the number of moles of KNO3 right now, but we can solve for it. We can solve for it with a little bit of dimensional analysis. And for every 1 mole of KNO3, we have a certain number of grams of KNO3. And that is going to be the molar mass of KNO3. So for the molar mass of KNO3, we're going to take the mass of K, which is 39.10. We will add the mass of N, which is 14.01, and add the mass of 3 oxygens, which is 16 times 3. And once you do that, that's where we get a number here. Let me calculate that for you all really quick. 39.1 plus 14.01 plus 16 times 3. You would get a molar mass of about 101.11 grams of KNO3. Okay, so how do we actually calculate moles? Well, we just do 5.7 divided by that 101.11. And we have 0.056 moles or so of KNO3. Okay, so really there's just 2 parts of this equation. We figured out half of it already. We figured out the number of moles. Now we just have to figure out the number of liters. So we had 233 milliliters, but that's not liters. We can convert it to liters though. How many milliliters are in a liter? There should be 1,000. Whoops, 1,000 milliliters in a single liter. So if we perform that calculation, we'll do 233 divided by 1,000. And that's the same thing as just moving a decimal place over 3 times. So it's actually going to be 0.233 liters of solution total. Okay, and now that I know my number of moles and my liters, this is where I can just plug into my equation and solve it. So molarity is equal to 0.056 divided by 0.233. And that's going to get me 0.24, just 0.24 molar or so of KNO3 solution. Questions so far? All right, if you're watching the recording right now, I'm going to do a brief pause, just skip ahead until it's not paused. Alrighty, let's resume. So what is the molarity of a solution that contains 42 grams of KCl in a 7.98 liter solution? Okay, weird abbreviation for solution there. We have 42 grams of KCl, 7.98 liters of solution, and we're being asked for molarity again. So we can go ahead and solve for that using the exact same equation as before. We're looking for number of moles, and we're looking for number of liters here. In this case, I don't know the number of moles again. I have to solve for that. So 42 grams of KCl. Let's figure out the number of moles that may have. So in 1 mole of KCl, I need to figure out how many grams to put on the bottom to cancel out grams of KCl. I'm going to go ahead and solve that for you. If you look up the mass of K, we have 39.1 grams per mole in K. And the molar mass of Cl should be 35.45. If we add those together, you get a molar mass of 74.55 grams of KCl in every 1 mole of KCl. So if we solve this problem here, 42 divided by the molar mass we just got, we should get about 0.56 moles of KCl in our solution, dissolved in our solution. Now, do we have to solve anything for our number of liters? No, they gave us liters. So we can go straight to the equation. Let's do moles divided by liters and figure out our molarity. So 0.56 moles divided by 7.98 liters gives us our molarity, which is something like, oh, I did this wrong in my calculator. Gives us something like 0.070 molar KCl solution. You all have any questions so far? All right. So that's the gist of molarity calculations. Sometimes it can be a little trickier where they're like, here's molarity and here's moles. Can you solve for liters? But it's just like, can you solve for the missing part in algebra expression? If you encounter problems like that and you get stuck, please let me know during practice times. But other than that, we're going to go ahead and continue to our next concept here. Dilutions. It's kind of on the second part of the next page. So if we go down past these practice problems a bit, dilutions are, if we made a solution of sweet tea, the solute would probably be sugar. We're trying to prepare it with sugar. And the solvent would be like unsweet tea. So if it was not sweet enough, like to my liking, totally bitter, how could you increase the concentration of sugar? Probably two ways here. We can increase the concentration of sugar. We can add more sugar to make it sweeter, right? To make it sweeter, we could add more sugar. Okay, that makes sense. Okay, there's another solution that's like probably really inconvenient, but could also work. We can allow the tea to evaporate. And put it in like a, I don't know, a dehydrator or something, and wait for some of the tea to evaporate, and then it will get sweeter and sweeter as the tea evaporates. But also maybe the tea would taste stronger. So I don't know, that'd be kind of weird. Okay, now if the tea was way too sweet, how could I decrease the concentration of sugar? Well, we're not, yeah, it's too hard to remove the sugar. What can we do instead of removing sugar? We can add, you can either add some water if you want it to taste kind of watered down, or you can add more unsweet tea if you have some brewed. Basically, either way, we're basically adding more solvent to it to make it taste less sweet, to make that concentration of sugar go down. So this concept of what we just did, that is called performing a dilution. So we're going to talk about dilutions on the next page. Oops. All right, moving on. So on this next page here, I just want you to correct these drawings on the right. If you don't see the water level, it's kind of like this circle here. And you'll see that solution 1 has the lowest water level, solution 2 has a higher water level, and solution 3 has the highest water level. So first bullet point here, dilution or diluting is the process of adding solvent to a solution to decrease that concentration of solution. So just like we were kind of like making that sweet tea less sweet by adding more tea to it without sugar, or adding more water to it, that is dilution. So the actual moles of solute never changes. I didn't remove or add sugar from that sweet tea, for instance. Only the amount of solvent changes to reduce that concentration of solution. Hi.
Good day.
All right, so I want you all to look at the pictures to the right here. So just kind of like looking at solution 1 versus solution 2 and solution 3. Let's go through these questions together. The pictures to the right show a solution throughout a dilution process. So we can ask ourselves, which solution is the most concentrated? Which one has like the most solute and like per amount of solvent? Do you think it's 1, 2, or 3? I said the most concentrated, so it seems like it has the most amount of solute or the amount of solvent that's there.
1.
Probably 1. You can also think about it like there's this less space for those solute molecules. They're like all like smushed together. So we're gonna say 1. Okay, so another vocabulary term here, dilute. Dilute is the opposite of concentrated. So which one is the most dilute? 3, exactly, because everything's spread out. It looks like it's more watery. So question number 3, what happens to the volume as we dilute the solution? So notice solution 1, solution 2, solution 3. As you dilute it, it becomes solution 2. Then we go to solution 3 as we dilute it the most. So what's happening to the volume as we go from 1 to 3? Does it increase or decrease? It's increasing. We're increasing the volume. What happens to the amount of solvent throughout the dilution? So we're adding more and more solvent, so the solvent should increase. What about the amount of solute? Did we change the number of particles in there of solute? No, so they stay the same. We can just put an equal sign there to say it stayed the same. And then what happens to the concentration of the solution throughout the dilution? The concentration, is it going up or down? The concentration of solute should be decreasing. It goes down. Because notice, like, you can think of it like if something's less concentrated with sugar, then it's going to taste less sweet. So if I'm adding more and more water to sweet tea, the concentration of sugar is going down as I dilute it. All right, so we can talk about dilution all day in terms of like, oh, as this goes up, what goes down, things like that. But what really helps when talking about dilution is cold, hard numbers, like exactly how much did we dilute it by? Like, how can we calculate this? So we do have this straightforward equation here where we have M1 times V1 is equal to M2 times V2. So let's talk about what all that means. This is called the dilution calculation or the dilution equation. When you need to dilute a solution, you need to know at least 3 of the 4 following variables. That molarity or that molar concentration of what you started with, M1. The new molarity of the solution you want to make, M2. The volume of the solution that you start with, V1. And then the volume of the new solution, V2. So we kind of have this before and after situation, just kind of like how we were dealing with those gas laws. Now, the thing about molarity and volume is that it can be whatever unit you want, really, just as long as it's the same before and after. So for instance, volume can be in units of milliliters or liters. Either should be fine. So let's look at a couple example problems here, and then we should be done for now. So question 1, calculate the molarity that results when 250 milliliters of water is added to 125 milliliters of 0.251 molar HCl. Okay, so just breaking this down, it looks like we had a solution of some HCl with a certain concentration, and then we added some water to it. So that dilutes it down. I think the concentration should be lower than it was before. But the question is, how much lower? So let's use our equation to figure out how much. We have that M1 times V1 is equal to M2 times V2. And we can just talk about, what should all the values be in this equation? What's my M1, V1, my M2, my V2? So M1, what's my first concentration? Well, it looks like my solution started with this 0.251 molar, right? What's my initial volume? Looks like my first solution had a volume of 125 milliliters. Do I know my second concentration, my second molarity? No, because it says calculate the molarity that results, which means I don't know my final molarity that results yet. I'm being asked to calculate it. So I can write a question mark for that for now. And then my second volume, let's be really careful with my final volume here. I started with 125 milliliters, but then it said I added 250 to that. So I really have to make sure I do this like, well, I started with 125, I added 250 to that. So my final second volume is going to be those two added together, which would be 375 milliliters, exactly. Okay, so now that I know what I'm supposed to plug into my equation, I can go ahead and plug it in and then solve it using algebra. So for my M1, I can say I have 0.251. For my V1, I can say 125, and that's equal to, let's see, some unknown M2. I don't know what that is, so I'm leaving it as M2. And then times my final volume, which I now know to be 375. Okay, so I just plugged in the stuff into the equation as written. All right, so how do I solve for M2? How do I get that all by itself? So right now I'm multiplying it by 375. So instead of multiplying by 375, I'll divide both sides by 375. So let's go ahead and do that. And that will cancel out 375 on the right side. And I'm left with M2 is equal to whatever's on the left side. So the left side, I'm just going to calculate as is. You can plug that into the calculator as is. And you can do 0.251 times 125 divided by 375 gets you an answer of 0.0837 molar or so as our brand new concentration. Okay, so to double check your work, you could just think to yourself, does this make sense? I added more water to this and the concentration went down. Does that make sense? Yeah, it makes sense because the concentration is supposed to go down if I add water to it. It gets more diluted and concentration goes down as I dilute things. All right, second question here. Let's solve this. Suppose you wish to make a 0.879 liter solution of 0.250 molar aqueous silver nitrate by diluting a stock solution of 0.675 molar aqueous silver nitrate. What will the volume of that stock solution be that you would need to use? I think there's some typos in this question. I was getting confused reading that. But we do have some numbers, and we can make a calculation here. So we can use our equation. M1 times V1 is equal to M2 times V2. And we can think about all the things that need to go into that equation. And it sounds like the situation is that, maybe I have like this big container or something, but I only need to use a little bit of it for a lab. So I'm trying to take some of that out and figure out how much of it I need to take out to use for this lab. So that's the situation here. Now, it doesn't always have to be a before and after that you're doing here. It could just be like the thing you know about and then the thing you're trying to solve for. So my M1 and V1, my things I know about, I could just put in that molarity and that volume that they give me. So my initial molarity, I could say, for instance, 0.250 molar. My initial volume, I could say 0.879 liters. For my final molarity, I could say 0.675 molar. And then for my final volume, I don't know what this is. Question mark, I don't know. Thank you. I will solve for that. Okay, so let's plug this stuff into our equation and solve for our unknown volume that we need. It's asking us for that volume. So M1, I could put in that 0.250 times V1. I could insert that 0.879 is equal to M2, which is 0.675 times this V2, which is unknown. So I'm just going to leave it as V2. So now I'm solving for this unknown volume, V2. Right now, I just want to get it all by itself on that side of the equation. Right now, it's being multiplied by 0.6 0.75. So I'm just going to do the opposite and divide both sides by 0.675. All right, so that cancels out the 0.675 on the right side, but on the left side, I do have to plug it into my calculator. So I'm left with V2 is equal to whatever that left side is equal to. 0.25 times 0.879 divided by 0.675. And my brand new volume, it looks like it is 0.326. Okay, our question to ourselves is 0.326 what? What unit of volume am I dealing with right now? Is it?
Liters.
It would be liters because I started out with liters. So that means this equation spit out a number of liters. Exactly. So that's my final volume there. And that's how I use the dilution equation to figure out, what is the amount of volume I need? What's the amount of concentration I'm going to get or I'm going to need? If I change the amount of liquid or I change the concentration or something like that. All right. Any questions in this lesson? We good? So that's about the example problems I wanted to do with y'all. You will notice that there are more example problems here. So as part of your practice, you can go ahead and complete those. But that's all I had to teach y'all for today. I will post this recording momentarily as well.